Good morning. My name is Amy, and I'd like to welcome you to TriHydro's Connected Vehicle Technology Without the Cost. Today's session is titled, How to Leverage Third-Party Provider Infrastructure. We're excited to get started, but first I'd like to share a few housekeeping items. All attendees are in listen-only mode. If you have questions at any point, please use the question box in your GoToWebinar attendee panel. We'll save a few minutes at the end of the session for a Q&A after our speaker has presented. If we don't get to your questions in our 45 minutes together, we'll answer them directly via email after the webinar. Additionally, you'll have the opportunity to complete a short survey when you exit the webinar. It should take just a minute, and your responses are important to us and help us create valuable webinar experiences for you in the future. Finally, please be aware that due to the number of people viewing this webinar across the country today, we may experience slight bandwidth issues, and thank you for your understanding during this time of increased online activity and remote work. Now, I'd like to introduce our speaker. Mr. Shane Zumpf is an enterprise developer specialist with over 14 years experience as a software architect specializing in creating enterprise applications. Shane has authored and presented on connected vehicle, otherwise known as CV, topics ranging from the WYDOT CV pilot program to CV integration best practices within traffic management centers. Shane is the application development lead for the WYDOT CV pilot project and is responsible for the system design, application development oversight, and schedule, as well as testing. In his free time, you can find Shane out in the mountains, climbing mountains or trail running. Shane, I'll now turn it over to you.
Awesome. Thank you very much, Amy. Appreciate that. And thank you, everyone, for attending this webinar. We're going to go over how we can deploy connected vehicle technology without all of the costs associated with it. So we're going to run through a bunch of scenarios and be able to show real cost savings for state DOTs when they're deploying connected vehicle and especially connected vehicle messaging. Also talk a little bit about what messaging is and how it works in a state DOT environment. Most of what I'm going to be talking about today is really focused on stuff that we've learned from the Wyoming DOT's connected vehicle pilot project. Before I dive into all of that, though, I really wanted to go a little bit about TriHydro. TriHydro is a company that I work for, traditionally an environmental engineering consulting company. We also have a technology services and solutions business unit. This business unit, we do a lot of software development, mostly focused on environmental products and compliance. But in 2015, we actually partnered with the Wyoming Department of Transportation on the WYDOT Connected Vehicle Pilot Project. For the past 5 years, we have been really focused on building out a connected vehicle environment in WYDOT. We've come up to speed very quickly and are now one of the leading technology firms in the development of rural connected vehicle technology. We also have a really dynamic team of developers that have done everything from augmented reality to machine learning. So we have a lot of confidence in being able to beef up really quickly on cutting edge technology. Okay, a little bit about myself. I'm the application development lead for the WYDOT Connected Vehicle Pilot Project. Amy more or less went into more about my background and history, so I'm not going to dive too deep into this. But I did want to tell everybody a quick story on why connected vehicle technology, why it means so much to me, and why building out the WYDOT Connected Vehicle Pilot Project I see as being really important. So back in 2008, I was in the process of, my wife and I were going to be moving from Spokane, Washington, out to Laramie, Wyoming. My wife had just gotten her dream job. And so we loaded up a big U-Haul and started on our journey from Spokane down to Laramie. We get all the way down to Cheyenne, which is only about 50 miles away from Laramie. and decide to keep going. It was in the winter time, so January, February timeframe, and we got about 20 miles down the road from Cheyenne. Note that the weather actually was pretty nice. It was blue skies and whatnot. But this is essentially what we encountered about 20 miles down the road. The thing is that it had snowed a few days before, and the wind really whipped up. So this was a ground blizzard. We could barely see 5 to 10 feet in front of us at times. It was white knuckle driving for the next 30 miles. And I was scared, frankly, going through this section of road, and it took us about an hour and a half to get through it. Now, had I known, had somebody told me, hey, these are the sorts of conditions that you're going to encounter through this section of road, I absolutely would have just gotten a hotel in Cheyenne and held off on the journey going over to Laramie that day. It was that scary. So also wanted to play really quick a brief video for everyone, and just bear with me here for 1 second while I get this video up. If it'll pop up. There we go. Okay. Sorry, this is an accident that occurred along that same stretch of road that I was just talking about. And it's a giant pileup that occurred in April of 2015. So this is a spring snowstorm that really, a lot of these trucks are on a slight decline, and it's super foggy. It's not a ground blizzard, but it is, you're gonna hear a lot of impacts here from these trucks going into this pileup. I'm just gonna let this video play out for a little bit longer, just so you guys can get the impact of what I was talking about and my experience going through it and what we're trying to avoid with the pilot project. And just note that nobody was actually killed in this accident. There were some injuries, but no fatalities. Okay, so let's go ahead and move on. What are the current methods of communicating with drivers out on the roadways? Well, right now we're actually using a few different methods. We've got 511 apps that are typically done on a per state basis. And those really focus on being able to communicate current road conditions as well as sometimes travel times with drivers out on the roads. The problem with some of these 511 apps is that for truckers that are navigating multiple states, they would have to switch between 511 apps. It's not super practical for them to do so. We also need to be able to communicate that out to drivers out on the roads that they need to download these apps for navigating. The other way that we're actually communicating with drivers out on the road is through dynamic message signs. Dynamic message signs are actually really practical, really great ways to be able to communicate with every single driver out on the road. They've actually been shown to be able to reduce accident rates by up to 7%. So it's really effective, but it's also really expensive. So with an average capital cost of almost $157,000 per dynamic message sign, with an average estimated life of about 25 years, and then average operations and maintenance costs on top of that of almost $8,000 per year per DMS, it can be somewhat impractical to be able to deploy these statewide, especially over areas where you're going to run into multiple conditions that you want to communicate out to drivers. So what's a better way? What about being able to push messages to vehicles on the road as they're driving through sections of road that a message applies for? What if we could warn drivers of upcoming dangers? What if we could do it all within their vehicle themselves, right? So what we're talking about with the Wyoming DOT Connected Vehicle Pilot Project is being able to essentially put a dynamic message sign in a car. So whether that be through a tablet or a heads-up display or in the dash itself, right? Being able to communicate with drivers out on the roads, the conditions that they're going to be able to expect, perhaps travel times, variable speed limits, anything that you can imagine to be able to communicate to a driver out on the road that you want to, we can do that. How we do that through connected vehicles is something called the Traveler Information Message, or TIMS. TIMS are geofenced messages intended to inform connected vehicle drivers of situational data. Now, geofenced essentially means that we're talking about what one section of road a traveler information message applies to. So as you enter into a particular section of road, say it starts on mile marker 43 and it goes to mile marker 53, you're going to receive this message that you've got snow conditions or icy road conditions. What the WYDOT Connected Vehicle Pilot Project is actually using it for is for work zones, road conditions, road closures, parking, and blowover risks. Now, this is only a subset of actually what WYDOT's using it for and what we can actually apply for any state. So think of how this can apply to your state DOT, right? So if I'm Arizona and I want to be able to communicate out about sandstorms, you can actually create a traveler information message for that. WYDOT's also using it for variable speed limits in sections of road where we're trying to reduce speed based on some of these other road conditions. Spot weather warning impacts. We can do it for a whole host of information that you want to be able to tell drivers out on the roads. It's going to be able to better prepare them, just like I would have been able to be better prepared traveling from Cheyenne to Laramie that day. So let's also look at how a TIM actually works. So for Wyoming, we've got different sections that we are able to detect through road cams, through road weather information systems, also through our snowplows on the roads that are able to report road condition information back to our traffic management center. So say we have a snowplow that's reported snow and icy conditions in this section of road. Well, he goes back and reports that to our traffic management center. The traffic management center then updates their 511 system with those road conditions that apply for that road segment. As they do that, TriHydro's built out software to be able to help create these traveler information messages and then disseminate those to our roadside units that are installed along the roadway. Now, all of the RSUs that the WYDOT is installed are indicated by these little green dots here. So our traffic management center then pushes the messages to these roadside units. The roadside units then start broadcasting these traveler information messages to our connected vehicles, and a connected vehicle then encounters one of the RSUs. It receives the traveler information message. As it continues down the road, as soon as it hits the section of road that a traveler information message applies for, that driver will then see the alert on a tablet or the heads-up display or in dash. So in this case, the driver would get essentially a few icons on their tablet telling them that there are snow and ice conditions in the next in this road segment. So what are some of the economic and social benefits that we can foresee with traveler information messages? And mind you, all of these numbers that I'm about to show you, these are all estimates. And we think they're really conservative estimates because, frankly, if we're looking at a dynamic message sign that can reduce accident rates by up to 7%, And we're saying that traveler information messages can reduce it by that 1.1%, which what we've done here on looking at some of the economic and social benefits of traveler information messages. We think that's really conservative. Now, mind you, we don't actually have any solid numbers because the WYDOT Connected Vehicle Pilot Project hasn't completed yet. As soon as it does, we should be able to get some performance metrics from that and be able to look at some of the raw numbers and see if it actually, how much it reduced accident rates by, and how much we could actually see from benefits in this in the future. So this chart shows you looking at a 1.1% reduction in accidents, which again, we think is pretty conservative, what that would look like over time as the density of connected and autonomous vehicles grows in the future. So at the very start here, we wouldn't see too many impacts on cost savings, and these cost savings are federal and state portions of the accidents. So deploying emergency services and being able to do that. It doesn't really factor in a lot of the fatalities that are associated with it as well. So over time, you can actually see by 2035, with only that 1.1% reduction, we're looking at a savings of $200 million per year. And that's only going to grow as that connected and autonomous vehicles density increases. I also wanted to mention, I'm talking a lot about connected vehicles here. These same messages apply to autonomous vehicles as well. So autonomous vehicles can take in data such as you're going to encounter snow and ice, icy roads up ahead. It might choose to then switch over to rely on other sensors as opposed to the computer vision so that it can navigate through areas that are going to be dense in fog or dense in snow. So again, autonomous vehicles will absolutely need some of this extraneous information. Roadside unit. So what are the costs associated with deploying a lot of this technology? Well, let's look at some of the just raw hardware costs associated with it. So RSUs. And each RSU has a 300-meter range, and these are the equipment that you install along the roadside to be able to communicate with the connected and autonomous vehicles. So the RSUs with existing infrastructure run on average about a little over $4,000. That's including installation. When we're not talking existing infrastructure, when you have to bring in network, power, as well as install a pole for being able to mount the RSU on, you're now talking about an average cost per unit of almost $15,000. So we did a little bit of calculations in here. We did a mixed average cost of about $11,333 per roadside unit installed. That's throughout the states. So let's look at how many RSUs it would take for 100% coverage, right? For 100% coverage of all of our roads in the US, we're looking at almost $188 billion. For Wyoming alone, trying to outfit all of our roads with 100% RSU coverage, you're looking at almost 120,000 RSUs to be able to be deployed. And that's going to talk about a $1.4 billion price tag. Well, let's scale that way back. Let's say we don't need 100% coverage. Let's look at just 33% coverage. 1/3 of all roads would be covered by RSUs. You're still talking about $500 million. And I don't know about your states, but our states, Wyoming in particular, could definitely not afford $500 million, especially right now. So let's look at what if we could actually deploy connected vehicle messages and avoid all the costs associated with it. And that's what the WYDOT Connected Vehicle Pilot Project really had to do. We had to think outside the box. So they partnered with SiriusXM to be able to distribute these same travel information messages over satellite. And we really looked at using what was then at the time the USDOT's situation data warehouse. Now, the situation data warehouse, the US DOT no longer wanted to maintain that going forward. So TriHydro stepped up with the encouragement of WYDOT and took on the situation data warehouse. We renamed it to the situation data exchange. We thought that better accurately represented what it did. And then we built on top of what the US DOT had, more or less took the situation data warehouse as a core and really built a much better system on top of it. And so what does this look like in our architecture, and how does it work? Let's look at the WYDOT connected vehicle architecture. Now, this is a lot of information on here, and I'm not going to go through all of it, but I wanted to point out a few key facts here. On the left-hand side, you're going to see all the WYDOT applications that are feeding in to the 511 system, where we're able to communicate information out to drivers out on the roadway. And in the middle, we've got essentially the traffic management center system itself. On the right-hand side, we've got all of our connected vehicles. And just to the left of that, we've got all of the roadside units that are in this yellow box. Now, what I want everybody to really focus on is this area down below. This is the TriHydro situation data exchange and the satellite service provider, which is essentially SiriusXM. So we're getting data from the WYDOT connected vehicle system, and we're getting these connected vehicle messages. Those are then being distributed to SiriusXM, which is broadcasting those same traveler information messages over their satellite system. And then our connected vehicles have satellite receivers in them that are able to receive these connected vehicle messages and display them to drivers as they're going along the road. Let's look at a really simplified view of this. So we've got DOT traffic management centers. They're generating traveler information messages, depositing those to the situation data exchange. SiriusXM is then pulling from that. I do want to stress that there are other means of communication that we can push these same traveler information messages out by. We can do this over LTE, so any navigation apps that want to be able to use the same information can pull those same connected vehicle messages and use those to display to drivers out on the road. Vehicle manufacturers, OEMs, can then also use the same information that they can distribute to their vehicles over LTE or through satellite, and receive those same messages within their vehicles themselves. So this is something that we're expanding and we're looking into. But right now we're really focused on that SiriusXM piece, because they're the ones that have integrated with the WYDOT Connected Vehicle Pilot Project, and they've got a fantastic system for being able to distribute messages to their vehicles right now. So let's look at what this has done for Wyoming. Right now, for the Connected Vehicle Pilot Project, WYDOT wanted to, they were really ambitious here. We had 76 RSUs. We wanted to outfit 402 miles of roadway from the Nebraska border all the way to the Utah border. And we did that. We did that with 76 RSUs that we placed using a hotspot analysis. And so we had not really 100% coverage of I-80 because there were big gaps in between all of the RSUs. But using SiriusXM allowed us to be able to plug in those empty spots. Wyoming took it one step further, though. We've actually now enabled the entire state of Wyoming to be connected vehicle message enabled. Using the SDX, we're pushing messages for all federal and state highways throughout Wyoming. So right now, drivers that are connected vehicle drivers out on the roads can receive messages for all of I-25, all of I-90 in Wyoming, and all of our state highways as well. So it's something that we're really proud of, and we're trying to get out to other state DOTs that, hey, you guys can do this too, and you can do it by installing minimal infrastructure. So we didn't actually install any RSUs along any of the other roadways, but we're still getting the benefits of CV messaging. So let's look at a cost analysis. What does it take to outfit a 100-mile stretch of road? Let's just take an average 100-mile stretch of highway with connected vehicle messaging. And we're going to use a very, very conservative estimate of $4,000 per RSU installed. So I'm not using that mixed average that we're talking about of 11,333. The reason I'm not using that is because I want to be able to communicate out to everybody that the cost savings that you can actually get using the SDX. So if we look at 100% RSU coverage for that 100-mile stretch, we're looking at an average of about 300 RSUs. This is assuming that there's open terrain and you don't have trees that are restricting that 300-meter range for your RSUs. That's our first scenario. Let's scale that back. Let's look at a second scenario with 30% coverage where we have 90 RSUs that are placed using a hotspot analysis so that we're doing it in critical locations. But we're still going to have large areas of dead coverage for our connected vehicles. And we're still going to have to place out 90 RSUs. Let's also look at the third scenario where we have minimal RSU coverage. So we're still deploying 5 RSUs, but we're supplementing that using the SDX. And then if we look at the cost comparison here, you're going to see that the 100% RSU coverage runs us about $1.2 million. The 30% RSU coverage runs us about $360,000. And then the 5% is only about $20,000 to be able to deploy these. Operations and maintenance costs are going to compound that. We don't have good numbers on what O&M costs are for RSUs because they're cutting edge hardware really. So what that's going to cost in the future to be able to maintain these systems year over year, initially it might be pretty high, but you're going to want to factor in some base cost for being able to maintain those RSUs. I know in Wyoming we've already had to revisit these RSUs multiple times over the course of a year. So they're not like a plug and play system for the most part. I also wanted to run a different cost comparison here for dynamic message signs. So let's say we wanted to install 5 dynamic message signs along that same 100-mile stretch versus 5 RSUs using the SDX. You're looking at almost $800,000 for those 5 dynamic message signs versus the $20,000 for the RSU and the SDX. Now this isn't really a fair comparison because dynamic message signs obviously can reach a higher vehicle density, and the RSU with the SDX will only reach the connected vehicles that are in that area and are satellite enabled. But I still wanted to throw this out there just so you can look at how small the cost is to be able to deploy an RSU, the 5 RSUs with the SDX versus the 5 dynamic message signs. So what are our results really? Using the SDX for 100% coverage now, using the SDX results in a savings of almost, about $1.2 million over that, just 100 miles. Using the SDX results in a savings of $340,000 over a 100-mile stretch of road with only 30% RSU coverage versus the 100% coverage that we have with the SDX. And then the comparison with the dynamic message signs and the SDX with the 5 RSUs is about a $765,000 difference there. Operations and maintenance costs, again, are going to compound this. So you're going to really want to look at those costs and making sure that your DOT can maintain the RSUs going forward. I also wanted to stress that RSUs are still useful. It's not like you want to not deploy any RSUs. I told you that Wyoming didn't deploy any RSUs over that entire state area. That is one scenario you can go by. But if you want to be able to get information back from connected vehicles, RSUs are your method to do that. And that gives you a lot of also useful information on what your vehicle travel times are, if there are potential accidents or something to that in the area, vehicle travel speeds. So it gives you a lot of useful information coming back in from connected vehicles to your either traffic management center or traffic operations center into your DOT systems, essentially. So I don't want to discount that entirely. The other thing I wanted to touch on was the SDX spectrum, the SDX is spectrum agnostic. So connected vehicle, I'm sure you've heard about the whole DSRC versus cellular vehicle to everything sort of competition that we have here. And the FCC recently ruled that they were going to reallocate the spectrum that DSRC is currently using to cellular V2X as well as unlicensed Wi-Fi. Well, the SDX, since we're using satellites to be able to distribute these connected vehicles, is spectrum agnostic. So we don't really care about that fight, if you will, between DSRC or CV2X, because we're delivering these connected vehicle messages over a different path. So just something to consider, that your state can still invest in connected vehicle messaging without having to worry about switching technologies from DSRC to CV2X, or worry about purchasing a particular type of RSU that might be able to do both spectrums. So it's just another piece to consider, and something else that you can save money on while still moving your state forward with connected vehicle technology. So what are some of the features associated with the situation data exchange? Well, we took what the US DOT did with the situation data warehouse, and we really built on top of it. We added two-factor authentication for better security, including the data storage and retrieval portions of it. We also allowed so that only state DOT authenticated accounts are allowed to deposit message to the SDX. So you need to be either authorized by the state. In other words, we're not allowing any commercial entities into the SDX itself. We thought that this would be a much more secure way to be able to do things, and the data would be much more trusted. Also, we're looking at geographic restrictions here. And we're not looking at it, we've actually implemented this already, where what we're trying to do is only allow DOTs to be able to push messages related to their geographic regions. So if you have different districts in your state, and those different districts are responsible for pushing out messages on their own roadways, then you can essentially have different DOT entities signed up to the situation data exchange that are allowed to push messages for only their regions. So when we've got WYDOT in there, they're only allowed to push connected vehicle messages for Wyoming. They're not allowed to push out connected vehicle messages that are in regions in, say, Florida. Also, we've got TIM validation, where we are looking at TIMs, making sure that they are correct. They're formatted correctly, they're encoded correctly, and they also have SCMS certificate associated with them. So this is the other big portion. We are requiring all travel information messages that are deposited into our production version of the SDX to have SCMS certificates associated with them. SCMS certificates indicate that this is a good player or a good actor in the connected vehicle system. So we want to make sure that we're not circumventing that system. Also, another thing I wanted to mention really briefly was work zone data exchange. This has been a pretty hot topic lately, based on the US DOT's release of the grants for and pushing for work zone data exchanges. We see the situation data exchange not only for traveler information messages. We'd like this to be a central hub for all connected and autonomous messages. So the work zone data exchange portion is just another thing that we're working in here. And we partnered with WYDOT, Utah, and a few other states, Washington, South Dakota, to be able to also use the situation data exchange as a work zone data exchange as well. Again, that one-stop shop for third parties to be able to receive this information. We think that that's important going forward. All right, so this is super exciting for us. It's Raven. And Raven's our intelligent transportation system that we have developed here at TriHydro. It's a way for DOTs to ramp up really quickly on connected vehicle messaging. So we're building it such that we hope it's going to be more or less a plug and play system that your DOT can then take on and ramp up really quickly with connected vehicle messaging. Now, Raven isn't required to actually deposit the SDX, but it'll help you get there a lot quicker. We're looking for a few state DOTs to be able to pilot Raven with, and looking at integrating it with your systems. If you're interested in this, please reach out to us. We're looking again for a few partners to be able to pilot this project with. We've been working on Raven for a little while now and believe that it's going to be a game changer for the connected vehicle messaging environments, especially with DOTs. Getting started in resources. So now that we've got the SDX here, these are a bunch of resources that we've built out for states to be able to help them integrate with the SDX itself. So we've got an API definition here that will allow your developers to be able to go out, look at all the features for the SDX and how to integrate their systems with the SDX itself. We also have an SDX beta site for testing and a production site for being able to push your production travel information messages to. We've also got a sample deposit application that allows you to be able to see how we've been doing this in with our current systems and with WYDOT. So we think that these resources will help you get moving forward. If there are any questions on any of this stuff, we would also be absolutely more than willing to help you out and help you get integrated with the SDX. All right, so with that, I'm going to hand this back to Amy, and we can go over any questions.
Great, thanks so much, Shane. Now let's move on to our Q&A. If you haven't already, please type in your questions in the attendee panel in the Q&A section. We'll just wait a few minutes, few seconds. Oh, I see one coming in. Shane, how many message types does the SDX currently support?
Amy, that's great. Thanks for that question. So right now, the SDX really supports traveler information messages as well as works on data exchange messages. We are looking at expanding that to RSM support as well, so roadside safety messages. And that's really the second generation of traveler information messages. So we will support those as soon as that standard becomes finalized. Right now, I think they're still working through a few things, and probably in the next 6 months or so, that'll become finalized. As soon as it does, we're going to be able to support that message set as well. The other two messages that we're looking at being able to support are map messages, which are essentially defining a roadway, and as well as we're looking into being able to support SPAT messaging on top of all of that. So SPAT messaging is a sort of another beast in of itself, so there's a bit more that we're going to have to work in there, but it is on our roadmap to be able to support.
Excellent. Thanks, Shane. We had a question come in from Matt. He is asking, has Raven been integrated into any existing ATMS platforms? Ours is IRIS, for example.
Yeah, so we haven't actually integrated this with any ATMS platforms yet on Iris, but we are building it such that it will be able to be integrated really easily with any traffic management system. We've taken what we did with WYDOT, and WYDOT has built out a system. Most everything is customized at WYDOT for their applications on their 511 systems. Now, what we're doing with that one in particular is building an API that can integrate there, and then building modules that plug into there and more or less intercept messages. Now, we're building Raven such that it not only will be able to integrate with ATMS systems, but it'll also be able to look at data feeds that the ATMS system is providing and generate connected vehicle messages off of that. We still need to look into DOT systems themselves with Raven, just because that SCMS integration really, we'll build out Raven such that you won't really need to worry about that system too much. You'll just need to work to get that system up and running, and we can help you through that process as well. But as soon as that is there, then Raven will be able to integrate with your ATMS system and be able to push out messages to the SDX as well as your RSUs.
Great, thanks, Shane. A question coming in from John. Did you see a degraded performance in wireless communication, for example, Sirius XM or DSRC, during snowing conditions?
So that's a fantastic question. We have not seen that yet. It seems like DSRC does go through snow fairly well. So we haven't seen like a big degraded performance there. We have limited results in the snow right now. So again, over the wireless communication, we haven't seen too much of a performance degradation right now.
Okay. Another question from Mark. What type of data would a DOT need to share in the pilot? And the second question is, what are the benefits to a DOT of joining the pilot program?
Oh, those are great questions. So on the pilot project itself, I'll go over the benefits first, and then I'll talk a little bit about how we would work together to be able to bring you up to speed with Raven in and of itself. So some of the benefits of joining the pilot project would be we would do a much reduced cost on implementing Raven, because we want to be able to partner and be able to prove this out with your state DOT and be able to integrate in there for more connected vehicle messaging. We see this as we want to get these out there and be able to prove that that accident rate reduction. And we think it's so valuable to not only your state DOTs that we're really willing to do some in-kind services, as well as bring you up to speed on Raven for a reduced rate for at least the first X number of years. And we can talk about those details later. As far as the information that would be required from the DOT, it would be integrating in your ATMS systems, or being able to take out all of the road segments that you want to be able to have CV messaging applied for, and then us build out using either Arnold or some other system, be able to build out all of the road sections and segments, and build the traveler information messages for those. Also looking at, what messages do you want to be able to deploy? Right now, our system would be able to support a whole host of messages as well as custom messages. But if you want those same messages displayed to a driver in a way that is not distracting or anything, then we could work with you on that, as well as work with SiriusXM and Siemens on their OBUs that are satellite integrated.
Great, thanks, Shane. Speaking of distracted driving, one of the questions that came in, how are you ensuring that in-vehicle messages aren't distracting the driver?
That's another good question. So for the WYDOT Connected Vehicle Pilot Project, we actually partnered with the University of Wyoming. They had run some simulations using the onboard units and the tablets that we have installed from both Lear as well as SiriusXM. And we really worked with those companies to be able to track driver's eye and what the tablet was actually, the way that the tablet was communicating with the driver, to be able to minimize as much distraction as possible. The University of Wyoming did a fantastic job of being able to line out what was distracting and what wasn't distracting for a driver, and then feed that back into the systems to be able to minimize those distractions as much as possible and still convey as much information as possible to the drivers.
All right. So we've had a myriad of questions come in, but I'm not sure we have time to answer them all. Shane, how about one more question? How does that sound? All right. We appreciate everybody hanging on and listening up to the Q&A session. A question from Kevin: can this SDX system work concurrently with DSRC if necessary?
Absolutely, absolutely. So that the SDX, again, is spectrum agnostic. It doesn't, it's delivering the messages through third-party infrastructure. So those same messages, so say I think this is what you're getting at, say a connected vehicle receives a traveler information message for snow on road segment A, and it gets that same traveler information message either via LTE or satellite onto its device. It knows that traveler information message has an identifier on it to where that driver is only going to receive that one message on it for that same road segment. So it's not going to get multiple, there's not any conflict there, in other words, for that driver on the road. Now, that essentially enables us to be able to push out these messages in any medium. And DSRC, again, that spectrum is sort of up in the air. This is a way that we can still deploy this technology without having to worry about relying on DSRC, or whether that sticks around or it goes to CV2X. So we're really in that boat of being able to be spectrum agnostic.
All right. Well, we're approaching the end of our time. If you all have any additional questions, Shane's contact information is on the screen in front of you, as well as we will have an exit survey. There's an opportunity in there to request one-on-one time with Shane to answer additional questions and to discuss your state DOT needs. Also, please be aware that a recording of today's webinar, along with the PowerPoint slides, will be delivered to your inbox tomorrow. Thank you all for joining us today, and stay well.
Thanks, guys.